is Isaac Woodford. Today I'm going to be teaching you about odds and probability. Since you're new to this, I think you've probably heard about both and maybe think they're the same, but they're calculated totally differently. So I'm going to give you some examples. So right now, let's start off with probability. So let's say there's 5 doors and 2 of the doors have prizes. Okay, so draw 1, 2, 3, 4, and 5. So let's say door 2 and 1 both have a prize. So we're gonna find the probability of getting prize and plus other more stuff. So if you pick one door at random, what's the probability you'd win a prize? So since 2 doors are favorable, 5 doors total, so the probability is 2 out of 5. 2 out of 5. Or you can also write it as a decimal point or a 0.4. And when you see a decimal point like this, like point something, you can make it into a percent. So let's make it 40%. So you have a 40% chance of getting the prize, and then there's also a 60% chance you won't. So since that equals 100%, 40 is your probability of winning a prize. And when you get into harder questions, there's something useful to know. The probability of not winning is always 1 minus the probability of winning. To see how that works, think of 1 as a whole thing. So we're just going to think about 1 as a whole thing. All 5 doors, which we can also write as 5/5. So let's just write 5/5. Since 5 out of 5 is the whole amount, so they already match, we subtract the top numbers. 5 minus 2, since we have 2 prizes, so obviously 3, leaving 3/5. And 3/5 represent the 3 doors without a prize, and if you add 2/5 and 3/5 back together, you get the 5/5, which is a whole 1. Because winning and not winning together cover 100% of what could happen. So that's a probability. So now let's talk about odds. I made a little rubric from the example we used before. So this is where people kind of get confused. Odds measure the same situation, but instead of comparing favorable outcomes to the total, they compare favorable outcomes to unfavorable outcomes. So odds in favor equal favorable outcomes to unfavorable outcomes. I know that's a tongue twister, it can sound confusing, but it's actually really simple. So that's why I just wrote this rubric to kind of explain it really easily. So we're going to be using ratios. So like we know, the favorable / total is 2 out of 5. Since 2 doors of those doors had prizes, it's 2 out of 5. So favorable and unfavorable. So basically the favorable is 2, and it's not 5 for unfavorable because we're making a ratio. So unfavorable were 3 doors that didn't have the prize, so it'd be written as a ratio 2 to 3, and then it's just flipped around, odds against. So then unfavorable 3 and favorable 2. So let's try a little harder example now that you understand. So let's try a little harder example. So let's say a charity event was holding a raffle, and every 1 to 9, this ratio, tickets are sold. There is a free play that you can get. If 100 tickets are sold, how many tickets actually win? Here's how you work through it. So the odds to 1 to 9 means every one ticket there are 9 losing tickets. So 1 win and 9 losses in each one. That's a probability of 1 out of 10, or 10% right here of 100, which is 10 tickets that win out of 100 and 90 tickets don't win. The trick is to remember to convert odds into probability. You add the two numbers in the ratio to get a new total, and put the favorable number over the total, so the probability equals favorable divided by favorable plus unfavorable, how we talked about in that rubric. Thank you. I have a bit of time, so I already wrote the questions, but let's try something a little bit more advanced, combining two probabilities together. Imagine your school is raffling off a reserved parking spot for a month. There are 40 students who entered, and the draw happens on a random school day of the week, Monday through Friday. Before the draw, you decide to guess two things: that your name gets picked, and it happens to be picked on the day that you're thinking. So let's say Friday. What's the probability of both those things happening? First, the probability of your name being drawn is 1 out of 40. Second, the probability that it lands on the day you picked are 1 out of 5 of the school days. Since there are two separate independent events, you multiply the probabilities together to find what both will happen. So for example, you just times 5 and 40. So even though your odds of winning the raffle alone are decent, the odds of winning it and guessing the exact day are much smaller, 1 in 200. This shows how combining two events, even really simple ones throughout the week, can change the probability by a drastic amount. And it's a pattern that shows up anywhere. Multiple things could happen together, from games to real world planning. One last thing before I wrap this up: understanding probability and odds also helps you to see information that gets framed. Would you rather play a game that has a 10% chance of winning or a 90% chance of losing? Like, they're the exact same, but the positive framing usually sounds more appealing. Even though the real odds haven't changed, knowing the math means you're making decent decisions on real numbers, not how something is actually worded. Now, before I go, today we talked about odds, probability, and did easy examples, medium examples, and harder examples. Thank you for listening to my video lesson.